my name is Miniseti. I hope you all are staying healthy. Today we are going to talk about multiple linear regression model. We have already discussed about simple linear regression model. Simple linear regression model only use one independent variable in order to predict a dependent variable. But multiple linear regression model use two or more independent variable in order to predict a dependent variable. Multiple linear regression model use two or more independent variable in order to predict dependent variable. For example, student marks are dependent variable, study hours are independent variable. That means student marks depend on how much time they spend on a study. Simple linear regression model only use study hours, or we can say that simple linear regression model only use one independent variable in order to predict dependent variable. But student marks are not only influenced by study hours, student marks also influenced by their health, their stress level, teaching skill of their teacher, even student marks influenced by their home environment. A multiple linear regression model consider all these factors while predicting student marks, or we can say that multiple linear regression model uses all these independent variable in order to predict this dependent variable. In this diagram you can see, this diagram shows a simple linear regression model. On x-axis we have independent variable, y-axis we have dependent variable. This line shows the relationship between single dependent variable and single independent variable. But this diagram shows a multiple linear regression model. Here you can see we have so many lines which shows a relationship between one dependent variable with multiple independent variable. This line shows student marks influenced by teaching skills of their teacher. This line shows student marks influenced by their stress level. This line shows student marks influenced by their health. This line shows student marks influenced by their study hours. So we can say that multiple linear regression model uses two or more independent variable in order to predict dependent variable. As we know, multiple linear regression model uses two or more independent variable in order to predict a dependent variable. First of all, we will see multiple linear regression model in case of two independent variable. Here y is function of two independent variable x1 and x2. This is our equation. Here y is a dependent variable and we have two independent variable x1 and x2. A0 is intercept which shows value of dependent variable when independent variable is 0. On x-axis we have independent variable, y-axis we have dependent variable. When independent variable is 0, then value of dependent variable is OK. This OK will be called intercept, or you can say that OK will be called our A0, because A0 shows value of dependent variable when independent variable is 0. And A1 and A2 are a slope of regression line. Suppose this x1, this line shows influence of x1 independent variable to dependent variable. This much change in x1 independent variable will lead to this much change in dependent variable, and this slope shows our A1. So we can say that this A1 is a coefficient of x1 which shows how much dependent variable y will change due to change in this x1 independent variable. Similar, this A2 is a coefficient of x2. Suppose this line belong to x2 independent variable and shows this much change in x2 independent variable will lead to this much change in dependent variable, and this slope will be called A2, because slope basically measure how much dependent variable will change due to change in independent variable. And E is error term. In reality, this is not possible to include all independent variable. That's why we include error term in order to capture influence of all another independent variable which are not included in this model. Now we will see equation when we have more than two independent variable. Means we will see equation when we have n number of independent variable. Here y is function of n number of independent variable. Similar, y dependent variable, A0 intercept, A1 is coefficient of x1, A2 is coefficient of x2 till an xn. Here an is coefficient of xn and E is our error term. Now we will see assumption. linear relationship exists between dependent variable and each independent variable. That means change in dependent variable is directly proportional to change in independent variable. No multicollinearity. That means the independent variable should not be highly correlated with each other. Homoscedasticity. That means variance of error term should be constant. In simple term, value of error term should not vary so much as value of predictor variable change. Independence of error term, that means error term of one observation should not relate it to error term of any another observation. Error term follow normal distribution. As we know, normal distribution are symmetric and bell shaped, and in case of multiple linear regression model, error term should follow normal distribution. Now we'll see one example. Here we have a price which is a dependent variable. House size and bedroom are independent variable because price depend on house size and bedrooms. That's why price is dependent variable, and we have two independent variable, house size and bedroom. Price is dependent variable, two independent variable, house size and bedrooms. A0 is our intercept which shows value of a dependent variable when independent variable are 0. Means this intercept shows or you can say that this intercept predict price when bedroom and size are 0. A1 is coefficient of size. That means A1 explain how much prices change when size of house will change. Similar, A2 is the coefficient of bedroom which explain how much prices will change for each additional bedroom. Now suppose we have to predict price of a house which size is 2000 square feet with 3 bedroom. Now suppose we have to predict price of house which size is 2000 square feet with 3 bedroom. Value of a house size and bedroom is given, but we have to calculate value of A0, A1, A2. We will also learn how to calculate value of A0, A1 and A2. But for now, assume we have calculated the value of A0, A1 and A2, and value of A0 is 50 and value of A1, which is coefficient of house size, is equal to 0.2, and value of A2, which is coefficient of bedroom, is equal to 20. And now we will put all this value in this formula. Value of A0 is 50, value of A1 is 0.2, and we have to predict house price which size is 2000 square feet. So here we put 2000 and value of A0 is 20, and we have to predict price with 3 bedrooms. So here we put 3, and when we solve this, it will become equal to 5 or 10. So by this way, by using a multiple linear regression model, we can predict value of a dependent variable based on multiple independent variable. So this is all about multiple linear regression model. I think you got it, and thank you so much for watching this video. Bye, take care.